Hello everyone, welcome to Data Discovery. At this video, we are going to see the concept related to Pareto distribution. So, what is this Pareto distribution? Why Pareto distribution comes into the picture and why we are learning it? And then after the most important code, how we need to deal with the code, all in just one video itself. So, let's get started. So, the Pareto distribution that the we are learning it over here, it's also called as a power law distribution. Okay. So why it's called as a power law, that all we'll be discussing it over here. So first let's understand what is the Pareto distribution. It's a type of the probability distribution that is commonly used to model the distribution of a wealth, income, and other quantities that exhibits the power law behavior, where one variable to a power of the other. What does it mean? Okay, that very just. So it's nothing but if you are having x and y. So the y value, it's nothing but k constant of x of alpha. So there are properties also. If you will increase the alpha values, the distribution is quite change. So based on the alpha, it depends on the distribution. So distribution, you will be getting some of the changes due to alpha change. So that is the parallel distribution. So why we are learning it, and even the Pareto distribution is also called as a 80-20 rule. It's also called as a 80-20 rule. Very famous numbers. So most number of the distribution that we used to get in real time data, it's type of a log normal distribution or Pareto distribution. This type of the distribution of the we used to get, rarely we used to get it as normal distribution directly. Otherwise we need to convert it into normal distribution. But why this normal distribution again and again that we are learning it? Actually, what does it happens when we are when we are using the algorithm, the ML or DL algorithm, when we are using it? So at that moment we used to use this linear regression, logistic regression, something like that. So dealing with it and we getting an efficient model. Okay, by the normal data, it's very easy to do it rather than doing with the log normal skewed data, rather than dealing with the skewed data all. So, and there are one application also at that moment you can give. If you are following, if your data is following the normal distributed data, then you can find the area also. But if it's skewed data, then definitely you couldn't able to find the area by using a z-score. So there are various kind of the application related to normal distribution. In the parallel distribution, you will be getting something like this type of the distribution you will be getting. So this shaded part that I have done it over here, okay, it's nothing but area under curve will be 80%. That's why it's called as a 80-20 rule. Area under curve, which is 80%. And this part, it's nothing but 20%. Or my this part, this highlighted part, it's called as a 20%. And over here, 80. So what does it mean? So 20% people have 80 percentage of wealth, 20 percentage of people have 80 percentage of wealth, and 80 percentage of people have 20 percentage of wealth. Exactly, right? So there are very less number of the people who's having higher number of wealth, and there are very um, more number of the people who's having very less number of death. So it's a very good distribution. This type of the distribution comes again and again in your projects, and this will be discussing related to it, but a quite picture related to particular distribution. I hope it's clear. Now let's move to the code. I will be sharing my notebook in my GitHub link itself, so you can check it in the description box. So over here we have imported the Pareto distribution, like all the distribution to calculate the probability values. In my y-axis, definitely you will be having the probability values, right? So for calculating itself has the inbuilt ones. So if you directly put the Pareto and then after you will just calculate it, and then you will be getting a plot itself. Like over here you have imported the library also, imports from SciPy stats import Pareto. From that itself, the all the probability values, the distribution, how it actually looks like. So it actually plot it, and you will be getting it. So no need to do the calculation in manual format. Okay, this other type of the distribution which will be used in analysis purpose. So what kind of the data that you are following, and what kind of data it's needed, and how we need to read with it. So these are things that we need to do it. Okay, here what I have done, I have imported the seed. The same seed, if you will use, you will be getting the same data as I'm having, and I'm just use the alpha value is 3.0. Okay, you just hyper tune it. You just do it with some other alpha value. Your distribution will be quite changed. Okay, just check it with it, and over here I have used the Pareto, and based on that, if you will plot the histogram, you just see the data. It's it's a part of the parallel distribution. It's a type of the log normal distribution, but not exactly normal distribution. So I hope this all distribution like uniform, log normal, and Pareto distribution find it out so useful. Do like, share, and subscribe to the data discovery. I'll be coming across more videos related to data science, data analysis, ML, DL, and NLP related algorithms, and the most important projects. Thank you.